Welcome back. I hope you are ready for another exciting workshop here at TWiMLcon. Next up is Ariel Biller with ClearML on your R&D on MLOps from zero to hero in 2 lines of code. Ariel?
Hi, Sam. Thanks. Let's get it started.
All right.
Can everybody see my screen?
Take it away. I'll be monitoring the chat and making sure that Ariel gets questions as they come in. If you're not currently participating in the chat, maybe because you're on the home tab on the event platform, just click into stream and you'll see the chat right there. And Ariel is anxiously awaiting your questions.
Yep. So, hi, I'm Ariel. I'm an evangelist for ClearML, and this is our session at TWiMLcon. I'm going to spend about 7.5 minutes talking about what does MLOps solve for routine R&D. Then I'm going to go and talk about how to get started with ClearML, show you the UI and what's important to know about it, really discussing integration of your code with our solution, show you how to do remote launching and experiment. And at that point, you're an MLOps hero. And I will show you by doing hyperparameter optimization with 2 Jupyter notebooks. Lastly, if we get time, and there will be no mishaps for live demos, praying here, then I'll show you some bonus parts of sharing and collaboration using the ClearML software as platform as a service. Okay, feedback for later, just add me on Twitter or DM me. And please note, if you're a DevOps person, I have omitted lots of content that is really actually appropriate for you. So contact me and you'll get that. Now, we begin with discussing what is machine learning and deep learning research and development. And I guess if you're here, you probably know it, but let's make sure that we're all on the same square here. This guy, we know him. He's on our team, or we are this guy, and he gives us the last 0.2% that we need to get the project started. But if you ask him how he got there, there will be either no answer or a different answer every time you ask him. And that's because 80% of the work is data cleaning or data wrangling, if you may. We're working on fast-paced research projects in multi-environments, skipping from one software to another, frameworks, the clouds, and all looking for the best model to get us approved, and really doing stuff that's beyond traditional continuous integration and continuous deployment, because the data is in there and there's tons of literature about it. But the gist is that there's just too many experiments, and there's a separation between our work and actually production. And someone who needs to deploy this is something I've heard. And the summary is that machine learning and deep learning research is messy. So what do? We put MLOps on it, right? MLOps is technical debt management, as I've discussed it in my keynotes in my session last week. And you can see this startup trying to adopt a cool deep learning application, and technical debt immediately creeps in. And MLOps is a way to mitigate that by automation, orchestration, and reproducibility. Automation, it means that if there's something manual, you do it automatically. If there's something automatic, you do orchestration, you can launch it whenever you want to. And reproducibility means that whenever you run the orchestration, you get the same expected result. And that's important. And I've added a 4th rung, which is important for what we're going to see next, is that whatever you do in MLOps has to integrate with your workflow, because if it breaks it, then productivity is going to tank and you've done nothing. And of course, in production, everything is MLOps because of automation, orchestration, and reproducibility is production. And you get model serving and data preprocessing. We've heard about feature stores. And you can actually go up to hardware configuration if you really want to. And you probably knew all that I just said, and your organization may have tried to remedy the situation by doing partial solutions. Maybe compartmentalization of work, maybe forcing you not to compartmentalize, to work on the cloud that you're actually doing the production. Maybe you need to commit for every experiment so you can have full reproducibility, quote unquote. Maybe you have a huge conda environment that everybody is sharing, that you won't have any package missing when you're running an experiment, and maybe you're forced to build your own containers manually every time you want to ship something, and maybe you have a central data model store that you probably forget to sync with, and overall you'll have a configuration overload because of all of the bits and pieces that you need to do in order to get it working. And that means that you have a high reproducibility overhead, and that means you have no reproducibility. And what I'm suggesting to use a platform. The platform is the MLOps platform, and you can actually build it from scratch if you have the money and time. If you're a big corporation, you might be able to do it, and you notice that there's a multiplier there, because whenever you build it from scratch, you will build it once, and then you will scrap it, and then you will build it again, because only then you'll know what you need. Otherwise, you might think that reproducibility is the whole story, and you just put on experiment tracking, and that's, again, only part of the story, because you won't get all the automation and orchestration out of it. And if you're smart, then maybe you say, I will assemble a stack from open source software, and then to glue it all together, we'll have to rewrite a bunch of code, add many YAMLs, and eventually, because there will be many moving parts, I'll still have the troubles in orchestration. And what I'm saying and suggesting is that you use ClearML for free. And what is ClearML? ClearML is an open source single solution towards lean stack MLOps. It means that there are no moving parts because it's a single uniform body doing experiment management, workload orchestration, data management, and more coming every day. And what we've taken into account is the need for a bottom-up design. You have something that works. You have something that you've already developed. You want to integrate it with some MLOps solution. It needs to be easy. And then the moment you've done this, you already get automatic logging and keeping of everything. And because you log and compare everything, you can actually do orchestration in one click. You don't need to set up anything else. And because you have orchestration, you have workflow versioning, which means pipelines, and add on top of that dataset and model management in the same package, and to top it off, remote session work debug, and you've got something that is really powerful. And as I said before, it's free. And I think it's because it's open source, it's been adopted quite widely in more than 1,000 organizations in more than 50 countries. And I want you to be organization number 1001. Actually, I think we've passed that already. My numbers are not that updated, but please check us out. And right now we're going into detail of why you should check us out. What's in the box? Well, it's a 3-part solution. One, you have the place where you're developing. We'll call it the data scientist environment or box. You have some Python code. It actually doesn't have to be Python, but I won't go into it today. If it's Python, there's a small snippet, 2 lines of code that you put, and the code is integrated with the system. The system is a server that you have to spin, and it's completely open source. It does the versioning and visualization of results, handles collaboration and data tracking, and of course, the all-important MLOps capabilities. But where is the compute? The compute is in a GPU machine or a very heavy CPU machine if you're doing machine learning, not deep learning. And that can be everywhere you want. You just need to install a Python package called ClearML agent, and it knows how to configure itself into the server and pull experiments that you want it to perform. Overall, again, experiment management, dataset management and lineage, model management, orchestration and scheduling, and remote development support. That is, you can unify these two. If you have very large data or you're unable to move data onto your own box because of regulation or compliance issues, you probably need to develop inside a container on a GPU machine, and you're finding it to be a hassle. Well, no longer. We have a solution for that, but I won't discuss it today. Just know that it exists. Today, we're actually going to see how hyperparameterization optimization can be easy, and discuss also pipelines. Now, some words about servers before I go into actual demonstrations. Again, the data scientist environment used for R&D can be either your laptop or your on-prem cloud, on-prem hardware or the cloud. The agent is for the heavy-duty compute. It can be on the cloud, on-prem, and sometimes even on your laptop. And I will try to use my laptop today. And lastly, the ClearML server, just to make certain that we're all on the same page, it's not for compute. You either spin your own, or because we know sometimes you're a small organization and you don't have the resources to do the DevOps for doing this, or because you're just checking it out before you go to the stakeholders and say, we want to use it, we are actually supplying you with a community server that's free to use and it's secure. And it has also actually support for team collaboration. We also have a live demo server, and I think you got a link for these slides. And the live demo server is for you to check out, and it's like zero configuration, but note that it's completely open and everybody can see what you're doing, and it resets every day. So it's really, really a live demo server. Okay, and now actually would be a good time to sign up. It's free. It's supposed to work, as I said, and you actually get 100 gigabytes of storage for your models, artifacts, and other things that you want to upload. And actually, if you sign in, and I will share an example in the end of this session on the main chat, if you're signed in, you can click on it and you get a read-only version that you can explore around. And that's one of the fortes of this. Okay, so getting started. Let's see if I can do this. Full instructions are on our documentation, but this is the abridged version. You sign up, as I said, or you spin your own server. Then you go to the getting started part of our documentation. It looks something like this. And there's a getting started. And basically what it says there is just install the package, generate the credentials on the website, that, and I'll show you it in a second, and run a small configuration utility to generate the configuration code. And then you move on to do the integration with 2 or even 0 lines of code. Again, this is something I won't discuss, but there's a link here that explains how it's done. And that's it, basically. We can now go over and look at the user interface. Where is it? There it is. Okay, let's full screen it. So this is actually the main dashboard of ClearML, and it really makes sense to discuss it after you've done some work. So I won't go into detail discussing it, but I want you to notice the question mark here. The question mark here gets you to the documentation you've just seen, and the Slack button gets you to our Slack community. And please join us. There's also a meme channel. Here will be the profile that you will use to generate the credentials. And down here below, we have the GitHub repository, and you're welcome to join and forecast or star us, please. Great. So you've probably seen dashboards for material design. And really, the point is that we've converged into a kind of design for the experiment management that actually lets you do research work. And what do I mean by that? It's compartmentalized, and you have projects. And inside the project, you have a very useful tabular view, which you can configure to your own content. You can add even metrics that you've generated in your code, in your runs, or hyperparameters that configure the actual experiments. And you can move stuff around and remove and filter out. And it's really good for a top-level view when you're actually trying to understand what you've just did. The same goes for the models. And that's the main view. Now, when you pick an experiment, you get the card view over here. That's a very space-optimized version. But what you get here is a drill-down view that can get you up to the image level of the experiment. And what do I mean by that? First is there's the execution tab, and we'll go into it later because we need it. But just note here that it holds information about how to reproduce the run. Then the configuration all the hyperparameters, and it's really easy to put them in here. Sometimes it's about zero integration effort. All the artifacts generated within the run. Right now in this run, there is no artifacts. All the info of when it started, maybe some notes, if it was generated as a product of another task, and results. And results is, I think it's a stronger version of TensorBoard for collaborative experiments. And why is that? It's because, first of all, you've got all the logs. You can download them. You can filter everything that was printed. If it's a local machine or a cloud machine, is here. All the scalars that you've reported, either captured automatically from TensorBoard or you've reported them manually, are here with the nice Plotly interface. And any plot, really any plot that you can think of in plot, can be found here. And all the images that you've reported, also again, either manually or for TensorFlow. And it actually works for audio and text as well. And there's full screen view. This is CFAR, so it doesn't really make sense to do a full screen, but I think you understand why I meant it's drilling down to the image level. And there's actually more features to do this. You can do it in full screen, but I want to move on with the demo. So let's leave it at that and go back to the main screen. Okay, now let's say I want to put my code into the system. You notice I didn't show you any code editor and I didn't show you any add task button. That's because it's a complete separation. Maybe you don't want your code to live in the application, and you don't have to. You integrate completely from within your work, and I'll give you an example. Where am I? Yeah. So. No, this is the second chance. Okay. Now, this is a very simple notebook. It does CFAR classification from PyTorch. And I'm going to show you the integration with ClearML. It's right here. It's part one. You import the object called task. And the second is you init the task object, and you give it a project name and a task name. Now, because it's a Python notebook and I want to have an external interface into it, I can't use the automatic parsing of the arc parser into an configuration object. So I need to do it manually, but again, it's just configuring a dict and doing connect. I think you'd find nothing really revolutionary about it. The only thing that's nice is when I'm running it, it will connect to the main server. And then I will get a task ID, which means everything is tracked. And there's a link here back to the website that you can see. Now, I don't think I should run everything because this is a laptop after all. But let's just see what it's doing. It's creating the data set and test data set, defining a network, defining the loss, the optimizer, creating a TensorBoard, creating a test function, reporting some images every 500 minibatches. There's some rule for the name. Nothing really unique. It's just a regular training, and so there is no more integration code. Even the saving, right? I'm saving a model, and you see that. Sorry, I just did something. When you're saving a model, right, like this, it's automatically captured, and the model is you can configure it to automatically upload to your own S3, GCP, or Azure buckets. Okay, so this is the entire integration. Let's go and look at it on the app. Here's my project, and I'm in this project, and you will see here TWiML image classification CFAR example, and it's still running because I'm here. And in the results, we'll see exactly what was printed onto the screen before. And now, why is this important? Okay, right now, all I've shown you is the experimentation tracking overlay. Everything here is just like you've seen a second before. But now the execution contains the repository that I ran from, the commit ID. This is the branch tutorial fixes because I fixed a bug and I'm going to push it later. The script path. Wait, what do you mean script? I just ran a Python notebook. Yes, but it is automatically converted into a script that you can run on remote. So instead of holding just uncommitted changes, and yes, we hold uncommitted changes, so you don't have to commit every time you do an experiment. Now it holds the entire notebook in script form. And what it means is that if I have a worker, if I have a compute that I can send it to, I'm able to send this thing onto it with one click of a button, and I will do it. But in order to do that, I need to discuss the agent itself. So, ClearML agent is an answer to the predicament of having to commit your work, update a YAML, build the container, launch the experiment, configure the bugs, rinse and repeat until you get an experiment running on your remote hardware. ClearML agent does all of this for you because all the tracking information is saved on the website, in the web app. You need to do no more than installing a package on your compute called ClearML agent, configuring it much the same way like you configured your own developer box to talk with the server, and then repeating it to any other compute node that you want to run your experiments on. It can be your desktop, your office computer, your friend's computer, whatever. And also you can use Kubernetes, but this is for another seminar. And let's just do it right now, okay? So I'm going to do pip install ClearML agent. Now it's installed here, so it'll be just a second, but this is it, you're done. You just need to do configuration, and then you need to start a daemon. And I have a queue that I created, it's called the laptop. If we have time, we can discuss queues. But once I've done this, okay, I have now a process that listens to the website, and if I assign work for it to do, it will do it. And now, there are actually two ways to do the work. Okay, one that you're just seeing, it's let's say call it bare metal or Vms mode. The daemon will actually recreate your work environment by, building from scratch a virtual environment and installing whatever you had installed on before and running the code on top of it. Means 100% reproducible. And the other thing, which I call Docker mode, is tag Docker. It's usually done on remote boxes. The daemon actually starts within a container that is built on the fly from your requirements and based on a main container that you can configure. We have a default, it's the NVIDIA one. So that means that whenever you're running the daemon in this way, everything works just right on your cloud environment. You don't have to install drivers or anything else. And also you don't have to manage 1,000 containers because containers are built on the fly. Other things that the agent can do is, again, Kubernetes. There's something called services mode and even more stuff that it does that are out of scope. So now I have an agent, as we just saw, and I want to do a remote launch for the experiment. And for that, I'm going to do use the worker pane to see my workers. So I have my laptop here, and I have actually a GPU because I want to run experiments on a GPU. It's another machine, it's on the cloud, it has the same configuration. If I click one of those, I can see GPU and CPU usages over time, and I can look at what queues it listens to. I can see that the GPU machine listens to the default queue, and the laptop queue is on my laptop. So that's great. And now I'm going to take the thing that we just did. It's still running on my Jupyter server. I'm going to right-click, and then I'm going to clone it. Okay. I'm going to give it a name. Let's call it remote. And I'm going to clone it. And now the magic starts happening. It's really magic because now it's a draft of an experiment that I can remote launch, but I can also do configuration changes without changing any code. So let's say I'm going to change the number of epochs to 4 and the base learning rate to half of this. So let's change the number of epochs to 6 and add me on Twitter if you know why I did that. So now I'm going to either go from here or right click here. I'm going to enqueue this on the, not on the laptop, it will take too long. And also I'm recording this, streaming this, so it's not a good idea. I'm going to enqueue it on the GPU queue. So what's going to happen right now is it's going to go and build the container, and actually it's going to find out that I've listed it as PyTorch. The package that I had installed right now is PyTorch CPU, and because it's a Docker on a container, it will convert it into PyTorch on GPU, install it, take the code, this converted script, and run it. And we can see it's actually happening right now. But we don't have to wait. We can go and discuss some other things, and we can come back to it later. What we can see is that the GPU and CPU are starting to work. We'll see the GPU later. Great. How are we for time? We are just great. Okay, so let me summarize what I've shown you, and we'll make a stop for questions, and then we'll go to the next bit. I've shown you that you have a free open source complete MLOps solution that you can use. I've shown you that it's nice and smooth, and it works, and it's easy to integrate with. And I've shown you that you gain one-click execution of remote work. And now we're going to combine all of this to do something more intricate. We're going to do hyperparameter optimization, which stems from all of the above.
But we are back, and this is an opportunity to ask questions if anyone has questions of what Ariel has presented so far. No questions in the chat just yet, so let's...
Great. That either means I've been super clear or really unclear. That remains to be seen. Okay, so as I said, we're going to do hyperparameter optimization. So let's go back to my Jupyter server.
Before we get too far, we did have a question come in. When you launch the daemon in a local machine without Kubernetes, how does it handle resource allocation, such as GPU, and how does it enqueue jobs?
Okay, so that's first of all, it's not without Kubernetes. It's really without Kubernetes, because you don't need Kubernetes at all. Kubernetes is an option, and there are actually several modes of work in Kubernetes. Now, you can configure the daemon to work with all the GPUs you have, sum the GPUs. You can actually make it run 2 daemons per machine, 5 daemons per machine. There is a lot of stuff going on behind the scenes to make everything work. And in terms of allocation, it's exactly this. It's exactly like doing CUDA visible devices, especially if you have several containers. I think that answers the question. And I think it's really it's been tested to work on really intricate workloads, and it's just fine. And if you find that allocation is somehow wrong or not as up to par of what you expected, just come to Slack and we'll sort that out. Especially, I want to note that data is cached when you download data, and if you're sharing data between tasks and they go instead of downloading packages and containers, everything is smartly cached. Great. Any more questions, Sam?
Just one for me. You mentioned that Kubernetes is an option. How tightly integrated is it into what you've done, and are there specific parts of the workflow that are supported on Kubernetes, or is it supported end to end?
Okay. What I've done is I'm really not saying don't use Kubernetes. I'm just showing you that it's possible to use without Kubernetes. Mm-hmm. Everything is supported within Kubernetes. We have whole, I think it's called Helm chart and whatnot, to just set up everything automatically on Kubernetes. And there are, as I said, 2 modes of working with the agent with Kubernetes. I think it's I don't think it's a CRD, if that means anything to you, but really I'm not a Kubernetes person. I'm a research person, as you can see. But really, there's not supposed to be any problem. I mean, it's been used a lot in production. So
got it.
Okay.
Thank you.
Okay, so where were we? Yeah, hyperparameter search. Now, you've probably seen hyperparameter searches. What I have here is kind of like an API that is easy to configure because you have the building blocks already working for you. So that means that you can run hyperparameter searches without changing the code that you want to do hyperparameter search on. And also you get parallelization, early stopping, all of that managed for you by the ClearML server. So it's really a one-stop shop for hyperparameter searches, and it works with any hyperparameter optimizer. Out of the box, without any configuration, the default is Optuna. There's some others configured tightly, but you can really you can inherit from a class and define your own. Now, the same thing as earlier. I'm importing a task, but now I'm actually calling it an optimizer task, so I could see a different kind of I could filter optimizer task out. And as I said, building blocks. So this is an ID for a task, for a cipher task that I already ran and made sure that it works. Again, it was a Python notebook, and now it's a script waiting for me to run. So now I'm going to define an optimizer object. And the optimizer object is a rich interface into all the stuff that you need to do in order to do hyperparameter optimization. And if you can see, it's platform unspecific. So the only thing that's Optuna based is only this part that you can just define Optuna. If you want to switch out hyperparameter optimizations, it's just a one-line change, which is, I think, is amazing. But now the whole point here is, I mean, this is something that it's again, it is a DSL. It is something that you need to understand, but it's just text, right? It's just a general number of epochs will change the parameter number of epochs. But there's a layer of protection here. Let's say I make a typo here. Let's say I call it base X learning rate by mistake. And I try to build this hyperparameter optimizer object. Sorry, so before even running, this thing will do validation for me and will say, uh-oh, I'm sorry, I could not find requested hyperparameter base XLR on the base task. So you've done something wrong. So that means I didn't have to execute anything just to find my bug, which saves a lot on the clutter. Now I have a good optimizer object. And notice I call this task TWiMLCon, the project. So there will be a project named TWiMLCon the next time we go to the app. And actually, optimization is cool. It's just doing this. And it means that actually my Jupyter server on this laptop is going to orchestrate the optimization process for me. Okay, it means I actually can write some code here to make the process my own if I want it. But no, let's just start the optimization. This is Optuna talking. That's it. Tasks are now being created, being taken from by the GPU queue in order to do the work. And afterwards, I have some code here to run that will give me some printouts to my task when it's done. And because it's a live demo, I can go and actually show you how it's going, okay? So this one is pending. Why is it pending? It's because the GPU task is, the GPU is held up with the TWiMLCon task I ran before, right? Let's see where's that at. Okay. What is it doing? It's on epoch 4, and I said 6 epochs. Well, no biggie. I can abort the task from here. That will just stop the process and free up the GPU for me. And I can see I already have what I've done up to here, which is nice. And now I can go back to my the TWiMLCon project and see now the first task is already running. So this is kind of powerful orchestration that you don't need to bug your DevOps about. This is why I was saying we don't need Kubernetes, because once the DevOps or you have installed the agent on all the compute nodes that you need to work, all your team can self-serve. It's that simple. So what's doing now, right now, is it's building the container, as I said. But luckily, I have prepared from beforehand the end result. Where is it? So this is how it looks like in the end. So it will take the template task, it will take it, which will change the name with the parameters, and it will run it. And actually, you see I've published these runs, so now they're write protected. But this doesn't say a lot. I can now add any metric that I want, and I think I want to add metric of accuracy. And let's put the accuracy where we need it, right here, and let's sort by the accuracy. And we have a winner. This is the parameter. These are the parameters that I want to see. And just, you know, to dot the T's and cross the I's, on the scalar of the main task, on the plot, sorry, of the main task, we will have a parallel coordinate plot like we should have. And because this is a toy problem, you shouldn't really optimize batch size and base learning rate in the same time, and ask me why. But this is exactly what you want to see. You see the I think it's a 3,000 optimizer in Optuna. It's really focused on doing a small number of iterations, playing with the base learning rate, and going forward in doing some other stuff. What do you do from this point? Right? You've run a small study. Let's take it a step forward, a step further. So first of all, you would just want to make sure that you do a small sanity test. I'm checking out 3 experiments, and actually I can. Why do I have this here? I need to compare the task. I need to get to this point of the screen, and I can't. There it is. Compare. Okay, I will go into compare in the end of the session a bit more, but I just want to see the changes in values. So I can see that these runs were early stopped. Okay, even and this one continued further, but I just want to make sure that the loss curves are okay, and that I actually see get changes in the loss because of the different learning rate and batch size. So sanity test is okay. And now what I want to do is do workflow parameterization. And this is like, if you thought everything was magic until here, now it's even more magic, because I have now a hyperparameter search that I know that works for me. It's an entire automation suite of everything. And I can also, because everything is tracked, I can clone this one. And I can say more power, like this. And I have a draft for the hyperparameter study. Actually, maybe I want to move it to another project. Let's move it to the TWiML. Okay. And now, again, it's the same as before. I can configure it differently, and now the configuration is the optimizer configuration. So I can actually raise the compute time limit, raise the number of GPUs, concurrent tasks, change the queue, whatever I want, and rerun this and make a bigger study with 0 code changes. And I think this really will seal the deal for you if you ever done extensive hyperparameter searches. And so 2 leftovers that I owe to you, right? Everything worked well. I didn't have any failures. I'm really happy. And now I can actually share and collaborate. Sorry, didn't mean to end the presentation. I can share and collaborate. Where was I? So let's go over back to the hyperparameter optimization. And you can see this one has a link symbol to it. It's because I already shared it before. I will share it again. This will give me a link. Any registered user with this link has read-only access to this task and all its contents. Okay, if you want the model that or the artifact that's saved for it, you can access it. So if I just want to give someone the model and all the training logs that made the model, it's just a matter of copying this link and posting it to the person I want to see. And I will actually post this link in a few moments when we finish this on the main chat, and you can see for yourself. And as I said models, there are actually models in this project. And this model has the whole lineage and the storage position for it. I didn't configure the automatic upload, but there is automatic upload. And as I said, you have 100 gigabytes on ClearML, so you can upload there. Have all the details that I need. I can further the integration and put the network configuration here, and even I can put the model labels if I really want to package this as something that I can later deploy. Actually, I can download it from here. If it's on the cloud, I will have a download here. Let's add a tag. I tag the model. I can say, hey, listen, I have model haha there. Just take it. It's all very, very user-friendly. Now, another thing you can do is you can actually share your entire workspace. And that's really if you're a team and you want to work together, you share. And then if somebody has set up his own agents and you want him or her to run your experiments and just put the results back onto your workspace, it's super doable. Now, the limitation for the free tier is, I think, 3. But I think it's enough if your team is just starting or just checking out. When you're scaling your data science and machine learning team, it's really easy to set up a ClearML server, and the instructions are here in the documentation. I mean, I said before I wasn't a Kubernetes person, but I was able to set up an entire setup of ClearML in 5 minutes, just following those instructions. Great. Last thing that I owe is the comparison feature. And as I said before, sorry, let's actually have a check to see what's going on here. I have, okay, 2 of them are already, one of them is still running, one is pending, but it's already doing iterations. So this is cool. This is day-to-day work with ClearML. You can go, you can immediately know what's going on your machine. I can see that the GPU is hardly doing anything because really it's CIFAR on a very strong machine. Can I tell you which machine it is? Not from this view. Okay. Network usage. Yeah, just some network usage. That's nice. Great. Now, I owe you the comparison feature. So, I can open the archive because I have some stuff stashed away from you guys. And there's a run from before called the same as I called this one, and an original run, and I can compare them. And comparison is a full diff. You can add as many experiments as it's useful to compare. And it will give you, and you can change the focus of the comparison by just carding this around. Now, this is the main comparison. And you can see exactly what's different between the configuration. You can hide identical fields and really drill down. So this one has the 2 models are different, of course, and the names are different, and the locations are different, and the installed packages are different because this one was on the Docker, this one was on the PyTorch Jupyter Notebook. Hyperparameters were different. This one has a base link rate of 0.2, and this is 0.01. Scalars are, of course, different. Plots are not existent. And debug images, well, debug images, because it's the same task, they are the same. But the predictions are different because the models are different. So I can actually scroll like so. On this experiment, yeah, this one is supposed to be a frog, but it's a deer as predicted, and this one is predicted as a car. So this is a really powerful feature, and it's my favorite one because I validated most of the platform doing the research in my previous position in this company, and this one really saved my behind multiple amount of times because I always do mistakes because I work so disorganized. Okay, so and we've done this and we've done this, and we're actually just about done. I really invite you to join our community. because we want more feature requests and bug reports. This is our model. We want your input because we want to make it better, and we are sure that we don't know how it's going to be in the future, because machine learning and deep learning research is evolving as we speak, and it's really different from what it's been like 3 years ago. It's a complete change of events. And if you have any questions, you just post on our Slack channel, or you just tag your questions on Stack Overflow with the ClearML tag, and somebody will get to it. And you can always find me at this address, or as I said, on Twitter. And if you've managed to stay up to here, just one last thing. We are here with ClearML, but the company name is Allegro AI, founded in 2016. We have a bunch of patents and publications. We've released what you see today as Allegro Trains in the past. We have, as I said, more than 1,000 organizations using it. We just rebranded, and we partnered up with some very big names because the vision is shared by everyone. We just want to make MLOps work for R&D and make your productivity and projects soar. And thank you very much. And now let's see if there are more questions.
All right, thanks so much, Ariel. We did have another question come in about private resource utilization, i.e. non-local. Is it supported, for example, private Kubernetes cluster in a VPC?
Actually, that's the main reason why we went open source. There are lots of on-prem situations, specifically in medical and defense, that you can't even call us to ask for help, because any detail from the system is completely classified, and you just pull the containers that you need, and you run it, and it's super supported. And it's we actually had incoming pull requests from people that are using it on private clouds and on-prem setups to make it easier for other people using it. So the community is really bustling. We have a lot of adoption from DevOps persons.
Great. Question from Thomas: does the solution manage the deployment of models as well? You showed training and optimization.
Yeah.
Does it also do deployment?
Yeah. So notice that when I said what we have on this lean stack situation, I said more coming. Okay. There are actually use cases. We've published some use cases that companies have used ClearML to do production, but those are cases where production are really complicated, and you would do a self-build for the production in any case. But there are several ways to do simple deliveries from ClearML. As I said, because you have the artifact storage and the model store and the task IDs, it's really not a big deal to do a simple POC for production, and you just come to the Slack and you see how people have done it. But I think it's safe to say that if enough people would care to clarify and define their use case, and we can find a base idea that everybody can agree on, that's going to go inside to be a default.
Got it. And so the idea with the way you're able to do it now in the POCs you mentioned is just to tie into the existing workflow in ClearML, or is it some other way?
Yeah. So obviously I have my method of doing stuff, and everybody will have his method of doing stuff. I think mine is great, and I've considered it like meta research by now. I've been and discussed so many ways of doing stuff with so many people that I think I have like a nose for what will work well and what will not. But really. Integration with the ClearML is a matter of minutes if it's a simple setup, and maybe 30 minutes if you have to integrate several parts. And we're actually working to make this even easier each day. We've just recently introduced ClearML task, which means that you can automate from the command line any bit of code, write it as a task, fully reproducible in our system. So that really is like, if you have even R code, you want to run it as part of your pipeline, it's there. Okay, actually, as I said, we were going to discuss pipelines. I forgot. We also have pipelines, and I have a specific talk for that. You can search for it, or just hit me up, and I will give you
Can you give
the slides.
highlights of the pipelines?
Yeah. So you've just seen me build stuff from experiments as templates, right? And using a separate script to orchestrate everything into a hyperparameter optimization without changing the existing code. So pipelines for us work the same. You build the pipeline using IDs of tasks that work. You can swap them out as you like, and you gain this parameterization aspect over it. So once you have a pipeline that works, you just clone it, change the parameters, you have a new pipeline that's guaranteed to work. And that's something that, for example, in Airflow, I don't think happens.
Great. Any more questions from our audience? One of the points that you made as we were talking about Kubernetes earlier that I thought was interesting was that you're a researcher, not an infrastructure person, and you were able to get it up and running, and you don't even, you're not worried about the Kubernetes bits, and you're still able to make use of the tool. Do you have a sense for what the typical user personas are for ClearML, and how folks typically staff getting it up and running and managing it?
Yeah. So let's take the example that we had before, like a very private on-prem setup. Okay, there is a DevOps person full-time on top of that, right? So this guy just needs to put the ClearML server container in the Kubernetes pod, whatever, and make sure that it allocates enough agent pods to do the work. And then it's the DevOps person job is over. Everything is self-served from the app. And you can set up services and maintenance tasks from within the app that will launch as separate tasks and do maintenance routine. You don't have to discuss anything with DevOps anymore. So it's really it's funny because the DevOps person gets more off the hook and less work from it, and therefore they're really interested in this application. And data scientists, they also love it because they're able to actually extend their workflows and do everything as they feel like, and without needing to stop and maybe discussing how to build the next container, or where the containers are held, or when will they have free resources. And we've seen like any kind of deployment. There are people buying DJX workstations like with the 4 GPUs, fractionalizing them with the MIG, and having like I think like eight imaginary fractionalized GPUs serving the whole team, one for visualization, for tasks, and all of that without the DevOps even knowing that there is something there, because it's a box in the office. So it's a complete solution, I think.
Great. All right. Looks like we don't have any further questions. Ariel, thanks so much for taking the time to show off ClearML and what you're up to.
And thank you for having us. It's been a blast.
Thank you.